It's good to have you once again.
Thank you, ma'am.
Today, in our computer electronics class, we shall be looking at logic gate. We shall be looking at what class?
Logic gate.
Thank you. In our previous class, we dealt with binary number. Do you still remember that?
Yes, ma'am.
Binary numbers are what?
0 and 1.
Okay, thank you.
Alright, binary numbers take us to our class for today, which is on logic gate. And of course, what are binary numbers? They are numbers that allow you to represent large data with zeros and ones. So what is logic gate? In defining logic gate, certain characteristics must be looked into. Of course, they are electronic circuits, but you have some set characteristics that must be adhered to, which are what? They are electronic switches, that it's either on or off. They operate only in binary, and of course they make use of 0 and 1. And having said this, we have 7 logic gates. What are they? We have the AND gate, we have the OR NOT, NAND, NOR, XOR, XNOR gate. Of course, all these gates are 7 in number, but the first 3 are regarded as the basic gates. Why are they basic gates? They are the fundamental gates that are recognized. Other gates are recognized, but they are formed from these other gates. Are we together? So, as we proceed, we'll see it. Let's pick on the AND gate to see what the AND gate is. So, AND gate, or it is a gate that allows you to have your output as high, that is as 1, if your inputs are all 1. That is, it's a gate that allows you to have your output to be high if all the inputs are high, where we have A and B as the input and Y as the output. Having said this, let's check on what a OR gate is, which is the next gate. A OR gate is a gate whose output will be 1, that is, will be high if any, in this case, either A or B, if any of the inputs is actually 1, if any of the inputs is actually high. Are we together? Fine. But what's the minimum input? The minimum input is 2, but definitely not 1. Definitely not just A, but we could have A and B to be our Y. And of course, it has a representation. How is it represented? For 2 inputs, we have A plus B. For 3 inputs, we have 3A. So, having said this about the OR gate, I will move further to check the third gate, which is a NOT gate. A NOT gate is a gate whose output is always the inverse of the input. That is, if the input is 1, the output is going to be 0. So with this, we will bring our class to an end, and let's have a little revision of what we've learned today.
That's about the 3 basic gates today. Who can tell us what an AND gate is? Yes, class. Oh, yes, let's have you.
My name is Akirele God's Gift. An AND gate is a gate whose output is high if all the inputs are high.
Please clap for him. Okay, so we have OR gate. Who can tell us what the OR gate is? Oh, yes, please.
My name is Uzama Emanuela, and OR gate is the gate whose output is high if any of the inputs is high.
Thank you, please clap for her. So far, so good. It's been an interesting class. Do we have any question? Oh, yes, please.
My name is Olale Kondamilola. My question is, what's the difference between the primary gate and the secondary gate?
The primary gate and the secondary gate. Because like I explained to you that the secondary gate is actually formed from the primary gate. The secondary gate is what? So the basic gates, the main gates that we have are the AND gate, OR gate, and the NOT gate. The secondary gates are formed. They are what?
Formed.
From where?
Primary.
Thank you very much. Any other question? Oh, in absence of that, it's been a wonderful time. It's good to have you in my class. And We hope to continue from here in our next class. Until then, it's bye from us at Government Technical College, Adidingbe. Bye.